I'm going to go ahead and clear my screen to give me more work space on problem 2. So problem 2, let's get this going. I'm going to change to blue ink, and let's go ahead and label this stuff. So we have our, let's see, our A is 1. See how there's nothing in front of that x squared? That means there's a 1 there. Our B is always going to be the one attached to that x, so that's -6. Our 2A is 2 times 1, which is 2. And then what else are we looking for? Our C in this one is 0, which means our AC in this one is 0. Now, do we need that? No, but I want y'all to get in the habit of labeling as much stuff as you can. So let's go ahead and solve this. So the first thing we're going to do, if you're wondering if you're stuck or not, go check what we're looking for. And what we're checking for is -b over 2a. -b over 2a is the secret sauce here. So -b over 2a. So my -b, remember, this negative is always going to be there. It's got to show up because it just so happens my b is also negative. We know what happens there at this point. My 2a is 2. Switch this over to 6 over 2 equal to 3. So we know that my vertex is 3 comma something. What do I do to find this point now? I have to go back to find k. I have to plug in this point, plug in this 3, the x-coordinate. So to find my k, we're going to do f of 3. I've switched to purple. F of 3. And remember, I'm getting it from here. This is my h, and I'm just going to plug it back into the equation, the original equation. And now I have 3 squared minus 6 times 3. Let's evaluate that. 3 squared is 9. 6 times 3 is 18. And then let's do it again. Equals 9 minus 18 is -9. So check it out. Our vertex is -9. So now we throw this all back together. I'm going to switch to black ink. We're going to switch this all together, and we have ourselves an f of x equals, find our a, which is 1. You can go ahead and write that. Write your a. Our vertex is at 3, which means it's a +3, which means our x is always lying, so it's going to be like that. And then our k tells the truth. And we're done. Okay, so I want to show you a trick for Desmos. You see this here? This is my original equation, and then this is my vertex form I found. I've already entered it into Desmo, but here's how you check to see if it's accurate or not. You can put in, ignore those two up here. See this problem we're working on, the green? I put this in, and then this is the answer I found. Mister, where's your A? Remember, if there's nothing there, it's a 1. Watch what happens when I put this up there. Boom. Check it out. That's how you check your work. If it's the exact picture, you know you've done this correctly. So that's the example 2.